Alright, hey everyone. Welcome to your first video. So we've talked about it a little bit, but some things to remember. Go at the pace that helps you learn. Number two, if I write it, type it, or if it's pre-written, you need to have that in your notes, okay? Number three, you can abbreviate where appropriate as long as you get the meaning of what's going on. I wouldn't abbreviate in your mathematical work, but if you're copying down like a paragraph of text, that's fine. And then four, pause and rewind as many times as you need to. Again, this goes at your pace, all right? And so you do what works for you. Some of you might need to watch a video twice. Some of you might need to watch a video just once, so that's totally fine. Alright, so this is what the title screen of most of your videos are going to look like. It's going to make sure you're in the right class, tell you the section we're working on, and then it'll say what the section is about. So today, in 1.1 for Math 6, we're going to talk about whole number operations. Alright, so here's our first question, and what you see is a bar graph, a couple, title, a couple questions, and then a little picture. So, I'll give you a little hint. You don't have to copy that, but you should look at it and appreciate it. I thought it was pretty funny. Now, the bar graph you do need to copy, okay? So the best thing to do when you're copying a bar graph is to just do a vertical bar, like that one right there, and then do a horizontal bar, like that one right there. And so you have what's called our y-axis and our x-axis, okay? Now on this one, you need to put your labels, number of people, and day, but you don't need to put every single increment there. We're only going to use these three actual amounts here, these quantities of 2,570, 3,145, and 3,876. So my bar graph would kind of look like this if I was taking notes. Alright, so just like that, I've kind of copied the critical information from there over to here, except one thing, the title, well, we'll just call it attendance, okay? Concert attendance, if you want. So there we go. That's just a quick shorthand way to copy that graph. So anyway, let's go ahead and copy our questions, and then we'll answer them. So question one, what is the total attendance for the 3 days of the festival, okay? Well, total attendance, so I have 3 days here. Seems to me that I'm going to add up the attendance from every day. And so let's do that. So we got 2,570, that's day 1, 3,145, day 2, and 3,876 from day 3. And we're going to add. So 0, 5, and 6 is 11, carry the 1. 7, 1 is 8, 9, 10, 11, 12, plus another 7 is a 9, so 19. 1 and 5 is 6, plus 1 is 7, and then 8, 7 and 8 is 15. 1 and 2 is 3, plus another 3 is 6, plus another 3 is 9. And there you go. We'll add a label here, so it's 9,591 people who attended this rock concert festival on whatever date it was. Okay, so the next question, what is the increase in attendance from day 2 to day 3? So we need to look at day 2 and day 3. Probably doesn't hurt to write day D2 or day 2 as 3, 1, 4, 5. Day 3 as 3, 8, 7, 6. So definitely increase from here to here. So increase usually means add, right? We're going to increase something, so let's add something to it. That's true, but what we're actually trying to find is the increase. Okay, so what is the add? Well, what we're going to do is the opposite. We're going to subtract to find the amount that was added to day 2 to get day 3. So 3,876 is day 3. We're going to subtract day 1, 3, 1, 4, 5. 6 and 5 is 1, 3, 7, and that's all there is to it. Okay, 731 more people came on day 3 than they did on day 2. Circle our answer. Alright, so one question down. Good job. Let's keep on rolling. So here we have a problem about French fries. So if you wanted to sketch a little picture of French fries in your notes, it probably wouldn't be a bad idea. It might help you remember kind of what's going on. So let's say a small order of fries in the cafeteria costs $1.25, and each order contains 35 fries. So on Monday, the school made $106.25 from selling fries. So there's the information they give us. We need to know all that. That's what you need to write down. So go ahead and get that. Pause the video, play when you're done writing. Okay, so question 1 here. How many orders of fries were purchased? All right, so how many orders of fries? Oh, let's see. What would I need to know? Small order has $1.25. Okay, so what I'm saying is if they made that much from selling fries, and we know each order of small fries costs $1.25, I think I can find it by taking that and dividing it by that. So this is a great opportunity to make sure we're good on decimal division. So what I'm going to do is set up the following problem. I need to take 106.25 and divide it by $1.25. True statement. But we need to set it up in long division format, so let me reformat this real quick. Alright, so we know that this is the proper way to set up this problem. The problem with the problem is that the divisor here has a decimal, and we remember that the divisor can't have a decimal, okay? So what we need to do is get rid of that decimal, but again, we can't just go in and erase it. So what we're going to do is we're going to move that decimal to the right enough times to get rid of it. So if I move it to the right and put it there, it's still there. If I move it one more time, now we have a whole number of 125. So that's what we want. But we're going to have to do the same thing over here. Move it once and twice again. Whatever you do outside, you have to do inside, okay? So we're going to rewrite the problem now with 125 and 10,625. But we're not going to put a comma in there because it could just muddy the waters. So this is the problem we now need to do. Alright, so can 125 go into 1? No. So we don't put anything above that. Can 125 go into 10? No, so nothing goes above that. Can 125 go into 106? No, also not. Can 125 go into 1,062? Stopping at that 4th place. Yes, it can. The question is how many times? Well, 125. It's kind of close to 100, but it's significantly more than 100 as well. So, man, I don't know. I'm guessing like 7. So let's try. If I take 125 and multiply by 7, you get 35, right? So 35, carry the 3, bring down the 5. Then 14, 15, 16, 17, and then 7 and 8. 875. I need it to go into 1,062. I bet I maybe can get one more out of it. So let's try. 125 divided by 8. So 5 times 8, 40. 8 times 2 is 16, plus a 4 is 20. And 8 times 1 is 8, plus 2 is 10. Oh, 1,000 exactly. Okay, so I've got to go to 1,062. And 125 will go in there 8 times. So I think that's actually going to be our magic number, 8, giving us 1,000. And what is 1,062 minus 1,000? We already know that's going to be 62. And because this number is smaller than that number, than our divisor, then what we actually know is that we've done it right. So last thing is bring down the 5. Okay, and how many times does 125 go into 625? So let's give us some more room and figure that out. All right, maybe like 5 times? Is that something good to try? Because 100 times 5 would be 500, and we have 25, right? So 5 more 25s would be 125. 500 and 125, I believe, gives us 625. So let's just make sure. 125 times 5. Okay, so you get 25. 10 and a 2, so 12, and then 6, bingo. So that was our magic number there. 5 goes in there 625 times, subtract, and guess what? We're done. Why? Because we have our answer up there. No need to bring down, write a decimal and bring down a 0. We're done. So 85. So what was that the answer to, though? Well, how many orders of fries were purchased? Well, they each cost $1.25, and in total they made $106.25. It means 85 orders. So there's really my full answer with my title. 85 orders of fries. Alright, so the next question of how many individual fries were sold? Okay, so let's look up here. How many individual fries? Each order contains 35, so 35 orders, or 35 fries in an order. And we just found out there's 85 orders. So I think what I'm going to do is this. Okay, so we're going to do this. Take the number of fries in an order times the number of orders. Okay, but see this x? We need to get away from that, okay? The book's going to kind of use that a little bit this year, but we really want to get away from that because we're going to start using the variable x to mean multiply, and so we need another symbol for multiply, and in math we also use the dot for multiplication. So whenever you see this, it's the same as that. So let's fill in. Number of fries in an order times the number of orders. Well, how many fries were in order? They told us 35, and it's probably not exactly 35, but it's probably close every time. Times the number of orders. Well, in the previous problem we discovered there were 85 orders placed. So let's go ahead and do that. Line it up. Again, it doesn't matter if the bigger one or the smaller one is on top, if they both have the same amount of digits, and they do. 5 times 5 is 25. 5 times 3 is 15, plus 2, 17. Remember, add a 0 placeholder. 8 and 5 is 40, so cancel that 2 out. 4, 0. 8 and 3 is 24, plus another 4 is 28. And let's go ahead and add 5, 7, 9, 2. Any decimals to add in there? Nope, there were no decimals in here, so no decimals to add here. And there we go. That is the number of fries, individual fries that were sold that day. 2,000, 975. 2,975 fries. Alright, so today is actually June 1st, so you are hearing this video from the past. It's me, the ghost of math past or something, I don't know. But I'm recording this video in the summer because, I'm getting ready. And my wife and I are about ready to take a trip to Durango, Colorado. And while we're there, we're going to take this cool train ride up the mountain and to the town of Silverton and then back. Okay, so this is an actual view from the train. So the person's sitting in a car and shooting a picture of the train in the car up there on the curve. And yeah, hopefully we'll be kind of looking right at that. Although probably, I think it's snow. We won't be seeing any snow in June, but it'll really be beautiful. So I'm looking forward to it. Anyway. We're going to do a little problem about this, okay? So the narrow gauge railway is the railway that takes cars up to Silverton and back from Durango, and each trip can take up to 85 people, okay? That's a full set of train cars, 85 people, and let's say on June 23rd when we go, 1,080 total people went. Each trip can take up to 85 people, and all the trips were full that day except for the last one. How many passengers were on the last train ride? Okay, so let's maybe condense some of this critical information and then solve. Alright, so I think I've given us a good setup to kind of input some good information and then kind of be able to take a step back and just look at some numbers and maybe figure it out. So the total riders, well, they told us from up here, and this is probably in your notes already, right? Because you pause it and, fill out what you need to do. Okay, 1,080 total people. Right there. Okay, 1,080 total people and 85 people on a full train. Okay, so total riders, 1,080 for the day. Riders on a full train, 85. Now, what about the number of full trips? As you look back there, we actually don't know. We don't know how many full trips were taken. Number of partially full trips, though, I think we do, right? Because they said all the trips were full except the last one. So there was one trip that was partially full. And then how about the number of riders on that last partially full trip? That's another thing we don't know. All right, and that's really the final thing. They said how many passengers were on the last train ride. Okay, so we also don't know this, but getting this will help us get to this. This is really our final question. So how can we figure this out? Alright, so 85 on a full train, okay, and there was this many riders, and we know there was one partially full train. So it seems to me that like 85 people got on and filled up, and then another 85, and another 85, and another 85, and another 85, and then maybe 80 people got on, and then maybe the last ride 60 people got on, or 40. Okay, so it seems that like 85 is going to go in here some amount of times, and there's going to be some left over, and that leftover is going to be the number of people that were on the last train, right? So, let's figure that out. I think division is probably the thing we're going to do, and knowing we're going to get a remainder. So I'm going to take 1,080, and I'm going to divide that. I'll give us a little more room here. 1,080, and I'm going to divide that by 85. So 85 going to 1, nope. 10, nope. 108, yep, one time. So subtract, you get a 3, 10 minus 8 is 2. Bring down a 0. 85 is kind of close to 100. 230 is kind of close to 200, so I think a good guess is 2. So let's see, 85, 2 times. 85 times 2 would give us a 10, 16, and a 17, so 170. So 0, 23 minus 17 is 6. So 60 people, all right, or 60. Maybe, I don't know what that means. Let's figure it out. Well, what did we figure out? This was the total amount of passengers on the train, and this was the number of people on a full train. So how many 85s went into here? How many full trains did we have? 12, okay? So that was actually the answer to this, not final question, but a partial question. 12 full trips. So one partially full trip, so we know there was actually 13 total trips. But how about the number of riders on the last partially full trip? Well, if we filled up 12 trips with 85 people, it means there's a remaining 60. And that's not just an arbitrary number, that's actually our answer. That is the number of riders on that last partially full trip. Why is that? Well, think about what happens when you have a division problem and you have a remainder as an answer. We take our quotient of 12, set a remainder of 60 over the dividend of 80, or the divisor of 85, okay, and then we have 12 and 60 85ths. 12 is the number of full trips were taken. 60 is the remainder, and in this case, it's really the remaining number of people on that last trip. It's the number of people out of the 85 that could have fit on the last train. So how many people are on the last partially full trip? 60 people on that last 13th ride. Alright, so this was an unusually long video because I want to take a little bit of time and kind of ease you guys into this and then take it slow so you get the idea they are going to speed up from here on out. But that is the process. Again, pause as many times as you need to get your notes and to really understand. I'm a whole lot less concerned with you having your notes than I am with you understanding the material. That being said, there will be note checks that are done, so you need to take good notes in the format we discussed in the beginning of the video. Having said all that, thanks for sticking with it, guys. I will see you in class.